Assalamu alaikum. This is chemistry 12th, and our today's lecture is about aldehydes and ketones. Now, as far as these aldehydes and ketones are concerned, both these class of compounds, they contain a carbonyl group. That is a CO group. They contain which is in both aldehydes and ketones we have got this carbonyl group. So they are we can thus call, so they are collectively then called as carbonyl compounds. Now in case of aldehydes, we see that that this carbonyl group, it is linked to an aryl or an alkyl group and a hydrogen atom, whereas except in case of formaldehyde, where we have got where we have got this carbonyl group, it is attached to the two hydrogen atoms, whereas in case of this ketones, this carbonyl carbon, it is linked to two alkyl groups, which it may be two similar alkyl groups, or it may be an alkyl or an allyl group. You can see here this is an aldehyde. You can see here this is a carbonyl group and it is attached to an alkyl group plus an hydrogen atom. Now this is a ketone. Here you can see that this carbonyl carbon, it is linked to two alkyl groups, whereas in case of formaldehyde, which has got formula CH2O, we see this carbonyl carbon, it is linked to the two hydrogen atoms. Now as I have told you that the functional group, functional group in case of this aldehyde, in case of these aldehydes, it is this CO group, CO, which is where we see carbon is linked to an alkyl group and an hydrogen atom. Now as far as their this preparation is concerned, we'll discuss the methods of preparation. Before I will give you here an example. You can see here this is formaldehyde, or it is opaque name is methanol, since we have got only one carbon atom in case of formaldehyde. Then we have got acetaldehyde, where we have got these two carbon atoms. We have got a methyl group, and this is aldehyde formyl group. So acetaldehyde, that is its common name, whereas the opaque name is ethanol. Then similarly we have got this propanaldehyde, where we have got three carbon atoms, and this is propanaldehyde, and its opaque name is propanol. Now similarly, as far as examples of these ketones are concerned, we have got this is acetone containing three carbon atoms, in which we see carbon is linked to two methyl groups. So it is a dimethyl, so it is dimethyl ketone, or simply we call it as a propanone or acetone. Similarly, we have got another ketone. I have shown here the example. This is ethyl methyl ketone, where we see this carbonyl carbon, it is linked to a methyl group and to an on one side, and to the ethyl group on the other side, or we can also call it as butanone now, or we can call it a butan 2-one, since this ketonic group, or this oxo group, it is at a carbon number second. Now as far as the methods of their preparation are concerned, we have got various methods for the preparation of these aldehydes. So one of the methods is that is by the oxidation of the alcohols. Now as far as this method is concerned, in this method these alcohols, they are oxidized using an acidified potassium permanganate, or we can also use potassium dichromate. These are the two oxidizing agents we use, that is potassium permanganate, or we can use acidified this potassium dichromate. So in this case, this we see primary alcohols, they are subjected to oxidation in presence of this oxidizing agent. It may be camphor, it may be potassium dichromate, and the product is an aldehyde. So this is a controlled oxidation. This aldehyde, otherwise this aldehyde may get then further oxidized to the acid. So this is a controlled oxidation of these primary alcohols, in which we get these aldehydes. You can see here I have shown here this is methanol. Upon oxidation we get methanol plus water. Similarly, ethanol upon oxidation using these using this one of either of these oxidizing agents, either it is acidified this camphor or acidified potassium dichromate. So ethanol upon this oxidation we get this ethanol plus water. This is one of the methods for the synthesis of these aldehydes. Then another method we have got, that is by catalytic dehydrogenation of alcohols. Second method is by catalytic dehydrogenation of these alcohols. So what we do in this method, we pass vapors of these primary alcohols or this finely divided copper at a temperature of at a temperature of 573 Kelvin, and the product formed is an aldehyde. I will again repeat, it is what we do in this method. We pass the vapors of these primary alcohols or finely divided copper at a temperature of this 573 Kelvin, and we get this we get an aldehyde. You can see here I have shown here this is methanol. When it is subjected to this dehydrogenation using this copper at 573, we get this is methanol, or it is also known as this formaldehyde plus hydrogen. Now you can see again here this is then ethanol. Again this is a primary alcohol, so upon dehydrogenation using the copper and at temperature of 573 we get ethanol and hydrogen. So this is another method for the preparation of these aldehydes. Then we have got another method, that is from acid chlorides. This is a well-known reaction. It is known as Rosenmann's reaction. So what we do in this reaction, in this reaction we see acid chlorides, they are reduced or reduced in presence of they are subjected to reduction in presence of this palladium deposited over barium sulfate. So this is a catalyst used in this Rosen-Mann's reaction. So what we do in this Rosen-Mann's reaction, acid chlorides, they are reduced using this palladium, using the catalyst palladium deposited over barium sulfate. This is used as a catalyst, and we get this an aldehyde is formed and plus HCl. You can see here this is an acid chloride. Upon this reduction in presence of this catalyst, that is palladium deposited over barium sulfate, we get this aldehyde plus HCl. Now you can use here, this is methanoyl chloride, that is its UPAC name, or we call it as formyl chloride. So upon reduction using this catalyst we get methanol, or we get a formaldehyde plus HCl. So this is another method, that is how we get these aldehydes from these using from these acid chlorides in this Rosen-Mann's reaction. Then we have got one. Similarly, we can use this ethanoyl chloride. You can see here. This is ethanoyl chloride, or we also call it an acetyl chloride. So upon reduction using this Rosen-Mann's this catalyst, we get this is ethanol, or we get acetaldehyde plus HCl. So this is another method. Then we have got one more method of the synthesis of these aldehydes, that is ozonolysis. So what we do, ozonolysis of alkenes. Now in this case these alkenes, in case of this ozonolysis, these alkenes are treated with ozone in presence of zinc dust and water. So we use in this case alkenes, they are subjected to this ozonolysis in presence of zinc dust and water. Well, you can see here this is 2-butene here. This is 2-butene. So upon ozonolysis it gives us we get an ozonide which on treatment with this zinc dust and water, it gives we get here you can see here this is we use water and zinc dust, and we get here hydrogen peroxide, and we get aldehydes. So in this case we get 2 molecules of aldehydes are obtained in this way. In this case, if we use this to butene. Now, if the alkene is unsymmetrical, then we get two different aldehydes. Or if we use an alkene like this, 2-methyl butadiene. In that case, that case, we can also get we get this this ketone is also obtained. Now the purpose of adding this zinc in this case, since we use zinc and water. Now zinc dust, it removes this zinc dust removes hydrogen peroxide, which is formed also as one of the products, because otherwise, if this hydrogen peroxide is not removed from the reaction mixture, it may oxidize aldehydes. It may oxidize these aldehydes to ketones, or it can oxidize this aldehyde to ketone. This is by ozonolysis. So one more method is, that is from Grignard's reagent. So from Grignard's reagent, so what we do in this case, the Grignard's reagent is treated with hydrogen cyanide, and it is followed by acid hydrolysis of the addition product. You can see this is hydrogen cyanide. I have shown here, this is Grignard's reagent, as this CH3MgBr. Upon reaction, it gives us an addition product. Now this addition product, upon this acid hydrolysis, it gives us here an aldehyde. You can see here, we get ethanol, that is acetaldehyde, plus ammonia and hydroxy, this magnesium bromide. So this is another method for the synthesis of these aldehydes, that is from this Grignard's reagent. Then we have got another method, that is by the reduction of alkyl cyanides with stannous chloride and HCl, followed by hydrolysis. So this is known as Stephen's reduction. So this is known as Stephen's reduction. And what we do in this case, you can see here, this is methyl cyanide. Upon reduction with this stannous chloride, we get we get an imine here. You can see here, and this upon hydrolysis, it gives us an aldehyde, that is ethanol is formed, plus ammonia is also obtained. So there are some more methods which are used for the synthesis of these aldehydes. We will discuss those methods in our next lecture, since time at our disposal, it is very limited. So this is for today, and we will discuss the other methods of preparation in our next lecture. Thank you very much.